All right, to wrap up this section, we're going to talk about arguably the most important part of the section, which is factor by grouping. But before we do that, I want to kind of make a note on something that, again, I feel students just don't think of, which is completely fine because, you're learning as you go, but don't think of as an option or don't see how it works. So kind of vague, but what I mean by is I'm just referring to this as the generic factor out a -1 tool. Very does not leave much mystery. But I see a lot of the times, and this will become apparent in very shortly what I do with factor by grouping. But if you have something like this, say -x squared plus 3x minus 2, and for whatever reason, you think that you can do something with this, but if the signs were flipped, then a very, very easy thing to do is just say you're going to factor out a -1. And you can always do that. You can do that to literally anything. You can always factor out a -1 if you need to for visual purposes or anything else. So if I were to factor out a -1, factoring is essentially just division, but you're still keeping it attached. So divide -x squared by -1 gives you positive x squared. Dividing positive 3x by -1 just makes it negative. And dividing -2 by -1 makes it positive. So also dividing by -1 is the same as multiplying by -1. It's just a -1 over 1, which is -1. So no matter what you do, multiplying or dividing it is the same. It just flips the sign. But you can turn something like this into something like this, where you have a -1 times this group of terms, but the signs have been flipped. And that might be more advantageous to whatever you're doing. So I just want to point that out. Now, with that, we talk about the main point of this video, which is factor by grouping. And this is a very important and crucial kind of step that you can use in factoring. And as you'll learn throughout the next couple of sections, factoring is what we're going to focus on a lot. So this is just one of the several methods that you can use to factor something. And more specifically, I'll kind of start reading through this and tell you when you should be using this. So factor by grouping, if you have 4 terms, so 4 terms like x plus b plus c plus d, and for some reason, ax, maybe by, c, z, d, f for variables. And for what, you can't combine those two, but you have 4 individual terms is what that means, and can't seem to find a common factor among all 4 terms. So that means that I can't pull an a, b, an x, or anything out of all 4 of these terms to factor something out. Then do the following. Number 1, split the 4 terms into 2 groups of 2. Does not matter how. And now, because this is very vague and does not actually give you much detail, I'm going to start applying these steps to this example. So this says factor x squared plus 3x minus 2x minus 6 by grouping. And you could combine this 3x and this minus 2x, but this is the way that this problem is given to us, so we'll just leave it as such. However, split the 4 terms into 2 groups. I'm going to split down the middle, but you don't have to, because as long as it is factorable, it won't matter. There is cases where something like this might not be factorable, and no matter how you do it, then it won't work because it's not factorable. But regardless of that, I made the example, so I'm going to assume it's factorable, and I'm going to just split down the middle. So I'm going to draw a line right there, and I'm just going to group these two visually. So I'll have x squared plus 3x, and then we'll say plus minus 2x minus 6. And so all I do is add parentheses. Algebraically, this did nothing. Again, it just added parentheses, so that's completely fine. It just is a visual grouping aid. Now our next step, step 2, factor out the GCF for each group. Now, we're not going to do prime factorization on these because I use small enough numbers where you don't need to use prime factorization. You can kind of just mental math your way through it. But take the greatest common factor out of x squared and 3x. And so there's no numbers that you can take out, but you can take out a common factor of x. So this becomes x times x plus 3. That's all you can take out. You're done. Plus, now what can I pull out of 2 and 6, or 2x and 6? Well, you can't pull out an x because 6 does not have an x, but these both share a common factor of 2. So I can pull out a 2, and I get 2 times negative x, and then 6 divided by 2 is 3. Now, in a previous video, I had shown that if you have something times, or x times something plus 2 times something, you can factor that something out as long as it's the same thing. However, this is not exactly the same thing. This is x times x plus 3 plus 2 times negative x minus 3. And so this is why I brought up the factor out a -1 tool, because it's exactly what we're going to do. This will remain x times x plus 3. However, we're going to factor out a -1 and make this minus 2. Now we have times x plus 3. This has now made these two terms identical. And that means that we can factor this identical term out from either of these. And so visually, you can make a substitution and say that this is just a, and you can factor out an a, or you can factor out x plus 3 if you're comfortable with that. Regardless, you're going to have x plus 3 factored out of x and -2 to leave you with x minus 2. And again, I'll do it anyways just to show you so you're not confused, but if I said, I'll make a little side note. If I said a is equal to x plus 3, then this would turn into x times a minus 2 times a. And from a previous video, or just factoring in general, you can see that you can factor an a out of here, and you get a times x minus 2, as an a is a common term between them. Now just replacing the substitution you made with x equals x, or a equals x plus 3, this can turn into x plus 3 times x minus 2. Either way you do it, if you feel comfortable just doing it right from here and understanding that you can factor out the same thing from either of these terms, or if you want to make the substitution first to visually help you, regardless, you'll end up with this answer. And so, starting with this group of 4 terms, you can successfully end up with its factors by using factor by grouping. And you might be thinking, well, what are the uses of this, or what is the application for this? And although you're going to see it very soon, one thing is that this will give you an important property for a graph, and in real world experience, this is an extremely important thing to be able to do. It appears in all engineering disciplines at high levels as well. So if you plan on doing something like that, you need to be able to factor. You need to be able to master this class to be able to apply the basics wherever they come up. But regardless, you have now just been able to turn something that's 4 groups of terms that did not have one common factor and split up into factors of binomials. With that said, we're going to do one more example. I'm going to split it on the middle again, because again, it should not matter as long as it is factorable. So we'll just split it up with parentheses. Again, the parentheses do not mean anything. They're just a visual aid for grouping, at least so far. They will once we pull out numbers. Now, the greatest thing I can pull out of xy plus 8y is a y. And you'll have x plus 8 afterwards. And if you want to check that, you can redistribute your y, but you should have the same thing. Over here, you can't pull an x out of both of these because 24 doesn't have an x, but you can pull a 3 out. So you can pull a 3 out, and that will give you x plus 8, because 3 times 8 is 24. Okay, and now we notice that x plus 8 is the same term multiplied by either of these. So you have y times x plus 8 plus 3 times x plus 8. So you have x plus 8 multiplied by both of these terms, which means you can factor it out of both of these terms. So this will become x plus 8 times whatever is left over after you factor, which is y plus 3. And that's your answer. So this and this, you couldn't even combine these middle terms. You had 4 terms, none of them had a factor in common, and none of them could be combined to simplify the equation, and yet you still were able to factor it into terms that are multiplied by each other. And so that's a very powerful tool, and it's one that you should get very good at. So practice lots. If you want to see examples, I don't know if I'm going to have any up yet for this what's the word I'm trying to think of, way of factoring, I guess. But if you want to see some, comment down below and I will, put up a video of more examples of factor by grouping. If you have any questions, leave them in the comments. And if you found this helpful, you should like and subscribe.